Alright, for today it's going to be place value and approximation. How place value is so important in approximation. Approximation in terms of decimal places, significance figure, approximation to the nearest place value and all that. Okay, now place value. Place value of a figure in a number at a particular number base is the level of significance of the figure. That's very important and key. Now, approximation of values is running up a value to the nearest place value. How? I've said a lot of English. How am I going to explain it? Don't worry, you're going to understand everything during the course of the lesson. Okay. Place value of numbers in base 10. We can have place value of number in base 2, which may be different from that of base 10. Okay. The first one here is units, denoted by U. Okay. Next is tens, denoted by T. After tens is 100, denoted by H. After that is 1000, denoted by TH. After that is 10,000, denoted by TTH. Next is 100,000, and we have million. Next is 10 million, 100 million, and billion. We still have more, but let's limit ourselves to what we can manage for now. So we still have 10 billion, we have 100 billion, we have trillion, and 100 dice. Now, coming back to the side, now we have what we call decimal point. There are 4 listed place value at the place value before the decimal. So after the decimal, we still have other place value. We shall not hop to 1 or up to a whole number. That is key. So every other place value you have here are not up to a whole number. So you have them like tens, denoted by small t. Okay, I have hundreds, like I'm having it here. So after that is thousands. I have 10,000s, 100,000s, and finally millions. Okay, so let's stop here. We can still have more. Okay, now these are the place values from units back here to million are the place value before the decimal, and here from tenth to millionth are the place value after the decimal. And I told you everything right from tenth down to millionth here are not up to 1, so they decrease in this order. So here is of more significance than the one here. Here is of more significance than the one here. Just like the same arrangement with this. Okay, we'll understand better. Now let's take a look at these few examples. Now we are to write out the place value of the colored figure 5, 7, and 3. And the 3 examples, we are to write out the place value of the colored figures, rendering our answer in words, figures, and index form. Alright, let's approach this. So we have 43,533.98. In this number, we want to find out the place value of 5, writing the place value of 5 in words, in figures, and in index form. Now, why all this? OBJ, objective questions, or the one we call multiple choice questions, might be tricky at times. That options can come out in different ways. You may be asked to write your answer in maybe index or words or in figures. That when you see your answer in the options, you should be able to get which is your answer. Now the next thing, let's write our place value on each of the figures that's made up this number according to the arrangement. So starting from here, here is the decimal. Okay, now 3 is a unit. The second 3 here is in tens. Now the 5 whose place value we're looking for is 100. 3 here is in 1000, and 4 here is in 10,000. That is key. Now small letter t is representing tenths, and small letter h is representing hundredths. Okay, I told you everything after the decimal is up to 1. Take note of that. In fact, a correction here. Anything after the decimal is not pronounced together. This is not 43,533.98. No, that is wrong. It is 0.98, not 0.98. Anything after the decimal, you call them one by one. Okay, now the affected place value here is 100, just like you see it indicated is 100. So we want to express our answer in words, in figure, and in index form. So the answer in words is going to be 500, because this is 533. Okay, so it's 500. Now in figures, you could write it as 500, or you write it as 5 multiplied by 100. So it could be expressed any of this way. Okay, all right, now in index form it could be expressed as 5 multiplied by 10 to the power of 2. Okay, so in your multiple choice question, your answer might be expressed in any of this way. Just know which one is which. The next example, I want to write out the place value of 7 in this number. Okay, so this is 33.2547. Okay, so what is now the place value of 7? So let's write out the place value. Of course, the 3 here is going to be in units. The last number before the decimal is always in units. Take note of that. Just like you have it there, the last number before the decimal is going to be in units. Now, next to it is tenths. After the decimal, here is in tenth, hundredth, thousandth, and here is 10,000th. And this is the affected place value. Okay, here is the affected place value. So how do we write our answer in words, figures, and index form? So our answer in words is going to be 7 10,000ths. 7 10,000ths. Now in figures, it's going to be 0.0007. Of course, 0.007. So here is the place value of 7. It is actually first, second, third, the fourth number. It's the fourth number after the decimal, like you have it. Okay, so the same thing here. Or it could also be expressed as 7 divided by 10,000. So if you simplify this using your calculator, you're going to have the same thing here. And in index form, so what is that going to be? That's going to be 7 multiplied by 10 raised to the power of minus 4. That's 7 multiplied by 10 index negative 4. Any question? Please leave it at the comment box. Okay? And if you are new, do remember to like, do remember to subscribe, and also hit the notification bell for any updates. Alright, the next example, we want to get a place value of 3. Okay? And of course, it's going to be units. The last digit before the decimal. Okay? So that's going to be, in word, it's going to be 3 units, or you say 3, and in index form, it's going to be 3 multiplied by 10 raised to the power of what now? Why do I always use 10? I'm using 10 because I'm working in base 10. So this is going to be 3 multiplied by 10 raised to the power of, anybody? Somebody is guessing wrong. You're saying 1. It's not going to be 1. It's going to be 0. Remember, any number raised to the power of 0 is 1. So 3 multiplied by 1 is still your 3. Be careful. Mathematics is funny and still trickish. So that is the trick there. Okay, now moving on now to approximation in decimal places. Our place value after the decimal. So when you say decimal places and place value after the decimal, we actually say the same thing. When you say decimal places, is you considering a specific place value after the decimal point. Okay, now let's take a look at 3.254379. Okay, so everything here are place value after the decimal. So here is a decimal point coming up in alignment with the decimal we already have. Now here are all the place value after the decimal. 2 is to 1 decimal place. It is the same thing as to the nearest tenth. just like you have it there. So when they say one decimal place, that is just a figure after the decimal, and it's still the same thing as saying to the nearest tenth. Alright, now to two decimal places. Now that's going to be two figures after the decimal, and here is the second figure after the decimal. Okay, so it's still the same way of saying to the nearest hundredth. Now three decimal places simply means the third figure after the decimal point, which is here. So it's the same thing as saying approximate to the nearest thousandth, just like you have it there. Four decimal places, that's going to be to the nearest 10,000, and so on. I believe that is understood. You can pause the video for you to ruminate and process what I've taught so far. Now, let's take a look at this example. We want to approximate 3.254379 to one decimal place, B to 5 decimal places, to 3 decimal places, to the nearest 10,000. Okay, now we'll move on. So to one decimal place is going to be a figure after the decimal. That will be a figure after the decimal, and that is going to be to the nearest tenth. We are saying the same thing. So as you see, it's been indicated by this arrow. So once that is done, you consider the next figure to reach. Place value we are considering. So after that, you consider the next figure to reach, which is 5. Now, is it approximable or not? Okay, now just listen. Any number equal to or greater than 5 is approximable. So starting from 5 up to 9, they are approximable. Now, any number less than 5, they are not. So categories of number from 1 to 4, they are not approximable. Okay, so 5 here is approximable. So we approximate 5 to 1, then add it to the considered place value. So that's going to be 1 plus 2, and that will give us what? 3 points. Our answer here is going to be 3. So this is the result of our approximation. Okay, so to one decimal place, we have approximated this to 3.3. Our final answer is going to be 3.3. That is, I will approximated this into one decimal place. Okay, now B want to approximate these into 5 decimal places. I just want to consider 5 figures after the point. That's the meaning. Okay, so what is now going to be the affected place value? Is 1, 2, 3, 4, 5. That is 100,000. So this is the affected place value. So having gotten that, we'll move on to the next figure. Is it approximable or not? This is 9. Of course, 9 is approximable. 9 is equal to or greater than 5. Yeah, that's the trick. So you approximate it to 1, you add 1 to 7. That is making 8. So we'll be having our 8 here. So all these are what we have here already. So our final answer is going to be what we already have here. 3.25438 into 5 decimal places. Alright, now to 3 decimal places. Now I want to approximate this into 3. So here is the third decimal place. So having done that, we're considering this place value. Then coming to the next figure, is it approximable or not? No, 3 is not approximable. 3 is not up to 5. So that is going to be converted to 0. Okay, if it is not approximable, it's going to be converted to 0. Then add 0 to 4, it still remain 4. So that's going to be 3.25, then 4. And that is going to be our answer, 3.254, 3 decimal places. Now, the last example here. Now, to the nearest 10,000. So here is the place value 3, 10,000. So coming here, considering the next figure, is it approximable or not? 7. Of course, 7 is approximable. So approximate 7 to 1, then add the 1 to 3 that we have there. So that's going to be 3.254. Then from the 4 we are getting from the addition of 1 and 3, 3. So that's how I've been doing everything here. Okay. So my final answer is going to be 3.2544. Alright, significant figure. Approximate the following to the corresponding significant figures as indicated. So I want to approximate 27,839.234 to 4 significant figure. So what are we going to be doing? We're going to be considering 4 significant figures here, starting from the first significant figure to the 4th. Okay. Okay, now the first question to 4 significant figure. So here, starting from the first significant figure, which is 2, down to the 4th significant figure, which is 3. Okay, we want to approximate 9 and approximate 9 to 1. Of course, it's approximable. So add 1 to 3, making 4. Okay, so making 4. So our 3 is going to become 4 and our 9 will become 0. So doing this, we have successfully approximated this to 4 significant figure. Now why do we retain 0? We need to retain 0 because 9 is still before the decimal. That is very important. 9 is still before the decimal. So you must retain this 0. Why? We have approximated it to 1, then it will become 0, then the 1 added to 3 becomes 4. Then you have this. So our final answer is 27,840, just like we got it there. Now the next one, I want to approximate to 2 significant figures. 2 significant figures. When you see SF means significant figures. You should understand that. So now the first significant figure here is not 0. It's not this first 0, it's neither this nor this. So this is 2 years the first significant figure. The next root is 5. These are the first 2 significant figures that we have in this number. So coming to the next number, which is 7, approximate 7 to 1, then adding it to 5, making 6. So we can say this is equal to 0.0026. Okay. Now here you can retain 0 or you may not. I said that again. Here you can retain your 0 or you may not. Why? Your 0 is after the decimal. Remember here we retained the 0. Why? The 0 is still before the decimal. It's still before the decimal. Now any 0 after the decimal might be retained or not. Okay, that is key. That is key. Let's take note of that. Now the last one is, we want to consider the first 5 significant figures. So here is 871.20. So the 0 here is the 5th significant figure, approximating the next number, which is 9. So 9 changed to 1 plus 0, that is going to be 1. Right, that is going to be 1. So our final answer is 871.21. I believe that is understood. Okay, now every other thing becomes 0 or they are not reckoned with. Alright, now other forms of approximation: approximating to the nearest 10, approximating to the nearest 100, and approximating to the nearest 1000. So how do we go about that? Now to the nearest 10, we want to approximate 9,564 to the nearest 10. We're still dealing with place value, don't worry, you understand it. Approximating this to the nearest 10. So what does that mean? Okay, now when you have 9,564, this digit is in between 2 10s. The first 10 is 9,560 and the next one is 9,570. Remember, we are considering 10 to the nearest 10. Okay, so after 9,560, then you can have this. Then the next 10 after it is going to be 9,570. This is the number we are considering. We got this number from the question. Oh, don't be confused. This is the question we are attempting. So 9,560. Remember, 9,561, 9,562, 9,563, then 9,564, 9,565, 9,566, 9,567, then to 9,569, then 9,570. Now it's clearer. The 10 before the number and the 10 after the number. Now, the question is, which one is closer to this among the two 10s? This one and this one. Which one is closer? That's the question. What's the answer now? 64. Is 64 closer to 60 or closer to 70? What's our answer? Of course, it's closer to 60. It's closer to 60. Why? 6 is the affected place value, tens. Right? Now, the number immediately after the 6 is now up to 5. If we are to work on it, this will become 0, and 0 added to 6 is still what? Is still 6. So the nearest 10 to this is 9,560. I believe you understand that. In fact, you must understand. It's necessary. If what we have here in the question is 65 or more than 65, then it will be nearer to 70, because by the time you approximate, you'll be having 70 here. Now, to the nearest 100. Okay, so 9,564. Still the same digit. We want to approximate the digit to the nearest 100. Now this same digit is in between 9,500 and 9,600. This time around is not the nearest 10, it's the nearest 100. So this is the 100. Here is the 100 before the number, and here is the 100 after the number. So these are the two closest 100 to the number. Now the question is, which of these 100 is the number closer to? So this is 564. Is it closer to 9,500 or 9,600? Question? Of course, it's closer to 9,600. Why? Now, approximating 6 is approximable. So 6 becomes what? 6 becomes our approximating value, which is 1, added to 5, that is 6 itself. And every other thing becomes 0. So this is 9,600. Why? Because of the 6 here is approximable. So adding 1 to 5 is 6. And every other thing becomes 0. And it is resulting to this. So here is the nearest 100. Okay, that is taken, I believe. Now to the nearest 1,000. The number we've been working with is in between 2,000. So guess which one is the first 1,000? That's the 1,000 before the number and the 1,000 after the number. So the 1,000 before the number is going to be 9,000, and the one after the number is going to be 10,000. Let's ask ourselves, 9 now is the affected place value because it is 9,000, right? Good. Now here is 5. Approximating 5, make it 1. When you add 1 to 9, what is it going to become? It's going to become 10, and every other number thereafter becomes 0. When you compute that, what do you have? If 9 becomes 10 and every other number here becomes 0, you have this, not this. So 10,000 is what is the answer. Alright, so that's all for today. It's nice being here with you. Too tired, sitting and relaxed. So still rendering your support. Please do like the video. If you're new, subscribe. And if what we're doing is really worth it, let your friend and your lovely ones know about it by sharing the link to these videos. Remember my classwork. I'm expecting your answers. I have a database where I receive them. So if you have done it, I really appreciate you, and I will give you feedback and appreciating message for attempting my question. Okay? Just tell one person about the channel every week. Goodbye. Wish you success.